This is going on page 75 along with the first page that we did yesterday. And so the first thing here is the horizontal line test. Okay, it was kind of mentioned yesterday, but so if every horizontal line intersects the graph of a function and at most 1 point, then f is 1 to 1. And 1 to 1 means that the inverse is a function also. So yesterday we graphed a parabola. I don't have that open, so I'm not going to go back to it again. So we had a parabola, and then, or actually we might have done it the day before yesterday. I don't know. At some point we were given a parabola, and then we graphed the inverse of it right on top of it. So one thing you've known about a parabola like forever is that it's a function, yes? Well, when we graphed its inverse, the inverse looked like this, which is clearly not a function, right? So we don't have to graph a function to figure out or graph the inverse to figure out if it is if the inverse is a function, because you can use what's called the horizontal line test. See, this is a function because it passes the vertical line test. This is not because it fails the vertical line test, right? Well, since we're reflecting in the line y equals x, before I ever draw or graph the inverse, if I did the horizontal line test with the original, then I would know that the inverse is going to be not a function. So basically, if you have a 1-to-1 function, that means the function and its inverse are both functions. You can figure that out graphically by using the horizontal line test, just like you would the vertical line test. Okay, so that's just a little FYI. Not sure how much that's going to come up, but I wanted to at least address it for that purpose. Okay. So now let's talk back through some properties of our inverse functions. So graphs of inverse functions are reflections in which line? Y equals x. So over here on this graph, this is the line of y equals x. Given a function f of x, so this is our function, this is f of x. Given our function f of x, the notation for the inverse function is f inverse, looks like a little -1 of x. That is definitely not new business. Rewrite that in here. So for functions and their inverses, we switch x and y, right? That's how we find an inverse. And this says the domain of a function is equal to the range of the inverse function. Because if we're going to switch every x and y, then the domain and range also gets switched, which was talked about a little bit yesterday, but we're going to look at it a little bit more in depth today. Then the range of a function is equal to the domain of the inverse function. Okay? So if all the x's and y's switch, domain and range switch as well. Everybody okay with that? Okay, so to do a little bit more practice, we're going to graph some stuff together. You are not going to be expected to graph these from scratch. You are going to be expected to recognize things, though. So when we look at A, you should recognize that this is what kind of function? What do you call it? What do you use this thing here? Square root. It's a square root function, right? And you should know what the parent function of a square root looks like. It looks like this. It's like half a parabola. Okay? That's what a square root function looks like. The only transformation that's happening with this is that it gets moved to the left and down. So we are going to plot this, but I'm just going to tell you which points to plot. We're not going to worry about having to plot this from scratch. So the first point I want you to plot is -3, -2. Then you're going to plot -2, -1. And then you're going to plot 1, 0. Ignore my green line for a while. For some reason, all of a sudden, I think I have this on a different mode than I usually do. They're not disappearing when I erase. So right now, you can just pretend like it's not there. So if we have plotted those 3 points, and I know what my parent function looks like, that's helpful because that is that gives me an idea of what the shape is. Then I can sketch in my square root function would look something like this, but better, always better. Always better than what I have. Close enough. Sorry, still don't like it. Oh, that's not good either. I'm going to give up. Whatever happens here is what's going to happen. Okay. All right, everybody okay with that? Then let's go ahead and graph the inverse. Okay. So let's graph the inverse. We've got, before we do that, my green line is there. Sketch in the line y equals x. I suggest you do it like as a dotted line. I just did mine as a lime green line because it's easier for me to do that up here. My line looked decent, so sketch in that line if you haven't already. Then we're going to graph the inverse. So if I have a point at -3, -2, that becomes -2, -3. The point that is -2, -1 becomes -1, -2. And then the point that is at 1, 0 becomes 0, 1. I did something wrong. Hang on a second. Oh, that's not 0, 1. That's, oh my gosh. There we go. I can't put the points right where I want them. Whatever. Good enough. All right. So then, and if you have an idea of how these work, this is getting reflected down here. This is getting reflected up here. So your shape then looks like this. And your two functions and your y equals x should all intersect at the same point. If it's not exactly the same, it should be pretty darn close. Okay. Everybody okay with that? All right, so now let's actually find our inverse function. But before we do that, we are going to write down what our domain and range are of our original one. I should have done that before I drew the pink one in. So let's just look at the purple one, okay, our original one. What is the domain of this function right here? What's the first x that I have? -3. And then I go all the way to where? Infinity. We never include our infinities. Do I include -3? Yes. Then my range, where do I start? For the purple one. -2, and I go all the way to where? Well, my range, I start at -2, and then is there anything stopping this? I mean, it's going to go really slowly, but are my y values going to keep getting bigger and bigger? Yes, they are, so I'm going all the way to infinity, and I include the -2. Now, I still believe in my heart that the best way for you to write your domain and range stuff is in interval notation, because you are just going from left to right or bottom to top. You don't have to worry about the signs getting flipped around and all that kind of stuff, because inequality notation becomes a hot mess sometimes. But things could be written in inequality notation for you, and you need to make sure that you can recognize that they're the same thing. So another way to say this interval for the domain is also to say that x is going to be greater than or equal to -3. And this would be y is greater than or equal to -2. Okay, so again, I prefer for you to write it in interval notation because I think that, I mean, I've done this for a long time, and that's where y'all overall have the most success of not messing things up, but you need to recognize that they're the same thing. Okay, we good with that? All right, so now we're going to actually find the equation for the inverse. So I'm going to change my f of x to y. I'm going to switch x and y, so x is equal to the square root of y plus 3 minus 2. So my goal is to solve for y. I might need to remind myself of that as I go along. My goal is to solve for y, so at some point I got to get rid of that square root. Can I square both sides right now? No. I could, but it caused me a whole lot of grief, and I definitely don't want to. So I'm going to go with a no. No is the best answer there. So add 2 to both sides. That's equal to the square root of y plus 3. To undo a square root, I'm going to square both sides. So this becomes x plus 2, quantity squared. Is that going to become x squared plus 4? No. And even if it was, or whatever it is, I don't even care. We're just going to leave it like that. That is equal to y plus 3. So then x plus 2, quantity squared, minus 3 equals y. So f inverse of x is equal to x plus 2 squared minus 3. And then I need the domain and range for this. Well, this is the inverse of our original, So since this represents x and this represents y, they just switch places. So for my inverse, my domain is from -2 to infinity, and my range is from -3 to infinity. Now, looking at my inverse equation there, if I were to take this right here and graph it, what kind of thing would I get? I'd get a parabola. Well, we did graph the inverse, right? It's the pink one. Is that a parabola? No. But our function and our inverse, they should be congruent as well, right? Because all we're doing is like flipping it around. But that's why we have to restrict the domain sometimes. If I graph this exact parabola, but only go from -2 to infinity, then I get the right side of the parabola, which is what I have here, which is the inverse of that square root function. Does that make sense? So that's why we have to constrict the domain sometimes. We good on that? All right. We'll take that as a yes. Let's go down to the next one. So again, you can kind of ignore my green line for a minute. And let's start by plotting this. This is a cube root function, so we're going to start by doing -2, -1. Plot that point. Then you're also going to plot -3, -2, and -1, 0. So it kind of looks like I could just connect them and have a line that's parallel to the y equals x line, but I know that this is not a line because that is not a linear function. This is a cube root function, so I need to have an idea of what the parent function looks like to be able to graph it. And so I'm just going to show you what that is. When I graph that in here, it would look something like this. Okay, you've got a point of inflection there at that first point that we plotted. And then, what is my domain for this? Good, -infinity to infinity. And my range? -infinity to infinity, good. All right, and then we're going to graph the inverse after we find the equation this time. So we're going to change this to y. Then I'm going to switch them. X is equal to the cube root of y plus 2 minus 1. So this works almost identical to the last one. So then x plus 1 is equal to the cube root of y plus 2. How do I undo a cube root? I cube it. So I'm going to cube both sides. X plus 1 cubed equals y plus 2. So then x plus 1 cubed, oops, goodness, x plus 1 cubed minus 2 equals y. So my inverse, f inverse of x, is equal to x plus 1 cubed minus 2. Then I need the domain and the range. Are the domain and the range going to be pretty easy here? Yeah, I would say yes, because they're both -infinity to infinity. So when I switch them, they're still the same. Kind of hard to mess that up, I think. -infinity to infinity, -infinity to infinity. So it was not necessary to restrict the domain here just by the nature of what the function is. So it depends on the function. Okay, so now let's graph this. I'll do the inverse. So if I have a point at -3, -2, that becomes -2, -3. And then my -2, -1 becomes -1, -2. And my -1, 0 becomes 0, -1. All right, so once again, it kind of looks like I could sketch in a line. I could also do something else. So I'm going to draw this, but I'm going to tell you right now it's going to be wrong, so don't copy it. That's kind of what these first 3 purple points look like, right? So if I just modeled that, I could do this. Ignore those little things. Do you think that's the right thing to do? No, because that just looks like some sort of translation, right? So you have to have a concept of what's going on, or you're not going to be able to understand how these graphs work. All All right, so instead, when I reflect it, I know that this part gets reflected up, this part gets reflected down, plus this is a cubic function here that I have. And so when I have the inverse, it's going to look something like this. Okay. What questions do you have? Do you have a question? Did I do something wrong? Oh, it's G. Okay. I thought you said D. That's why I was like, it's what? Okay, thank you. Yes. Thank you. Okay. Yes, sorry. I wasn't even paying attention to that. G of X, so that's G inverse. Thank you very much for that. Okay. Is that what y'all were whispering about? Why not? You can call me out. It doesn't bother me. All right. I mean, I hate that you have to call me out that I can't do it right to begin with, but all right. Are we all good then? Okay, good. Okie dokie. So let's flip it over. So now we're going to talk about understanding, again, the concept of what the heck is going on and how all this stuff works together and how we can interpret when we have real live problems here. So if C of M is the cost in dollars of M ounces of mangoes, what do the following tell you? Okay, so I have C of 12 equals 0.75. What are the units on the 12? Ounces. Okay, so this is ounces. And what are the units on this 0.75? Money, it's dollars, right? So I think if you think in terms of what the units are, it can kind of help you make sense of what's going on here. So what this means is that 12 ounces of mangoes costs 75 cents. You agree with that? What would B then? What would B be then? What does the 8 represent? Ounces. So this would be 8 ounces of mangoes costs what? 50 cents. And writing 50 cents, I think would be okay. I mean, it does say in dollars, so I feel like we should probably put it in dollars, but, and really money is probably the only thing where that's okay to kind of shift that just because that's how we talk and that's what happens. All right, now, C inverse of 3 equals 48. What are the units on the 3? Dollars, and the 48 is ounces, right? Because we're going backwards. So then we can say $3 buys 48 ounces of mangoes. Because we could write this as C of 48 equals 3, right? That's another way to write it. So C inverse of 0.75 equals 12. What does the 0.75 represent? 75 cents. So 75 cents will buy, or buys, I don't know why I'm writing it differently this time, will buy 12 what? Ounces of mangoes. Which if you look at A and D, they're almost the exact same question, right? Just one of them is written as an inverse, because I could rewrite this as C of 12 equals 0.75. It doesn't look like a 7.5. 7.5. Any questions at all? Beautiful. Let's look at this one. Suppose that W equals P of X is the average daily quantity of water in gallons required by a palm tree of height X feet. Okay? So what does the expression P of 25 represent? So P of 25, what are the units on the 25? So yeah, there's a P of 25 And from this right here, I know that it would equal W. Like I don't have an actual value like I did up there. That's okay. So I'm sorry, I think somebody said it. What are the units on 25? Feet. And what are the units on the W? Gallons, right? So P of 25, if I found that, it would give me a number that represents gallons, right? So P of 25 represents, and gallons of what? Water. Not only water, but it's the average daily quantity, right? So represents the average, oh my gosh, putting my words together, the average daily quantity of water in gallons, gotta have units on there. All right, for what? A palm tree. All palm trees? Of 25 feet. Okay, so P of 25 represents the average daily quantity of water in gallons for a palm tree of 25 feet, or a 25-foot palm tree, whatever. Your words don't have to be exactly like mine. They're probably not, because my brain is weird sometimes in the way my words come out. But what you do have to have, if you put it in your own words, is you have to have the P of 25, make sure you say average daily quantity of water, make sure you say gallons, make sure you say palm tree, and the height with the units, you know. So, but if your words were mixed around a little bit or whatever, that'd be fine. Okay? Everybody okay with that? All right, so this P inverse of 25, does that 25 have the units of feet on it? No, it does not, right? Because that's the inverse. If I were to rewrite it, I could rewrite it as P of X equals 25. And what would the units be on 25 then? Gallons. And our unknown is our feet, right? So that means that P inverse of 25 represents, well, P inverse of 25 would equal X, right? And so that represents the height in feet of what? Of a palm tree. That needs an average daily quantity of what? 25 gallons of water. What questions you got? You understand how to read that stuff and get it in the right orders? Okay. So then what does the equation P of V equals 50 tell you about V? And then it says rewrite this equation in terms of P inverse. So if I was going to rewrite this as an inverse statement, then it would be P inverse of what? 50. And what would that equal? V. Okay. Wouldn't P of X be P of W? No, because what this is, P of X equals W. This would be P, so P inverse of W is what equals X. That's when the W would go in there. Does that make sense? Because your W is like your Y. So when you take the inverse of the Y, you get the X value. So here I would have, I could say that that is equal to X. Does that make sense? It's a very good question. All right, anything else? Okay. So on C, What does V represent then? The only thing it can represent is either the height or the gallons. It's the height, right? Because this is the gallons, so this is the height, it represents the height. It's almost identical to B, right? We just, instead of giving us a number or using X, it's using V, but it's the same thing. So V represents what does it represent again? The height. The height in what? Feet, in feet of a palm tree. And then basically the same as B. So if you want to reword that in your own words, I'll write mine and then we can kind of see if we agree or whatever. Of a Okay, so I said V represents the height in feet of a palm tree that needs an average daily quantity of 50 gallons of water. Do you agree with that? Okay, and if your words didn't land in the exact same spots, as long as you said all the right things, then we're good. Anybody have any questions about their wording or anything else? Okay, so let's look at D. It says palm trees are an average of Z feet high, and a tree of average height requires K gallons of water. Represent this fact in terms of P and P inverse. So we're going to need P of something equals something, and P inverse of something equals something. Okay, so let's figure out what those somethings are. P of, are we taking the P of the height or of the gallons? The height. And height is represented by what variable? Z. So P of Z is equal to what? K. So that means P inverse of what? K equals Z. Okay, you're just undoing it. We good with that? What questions you got? Anything? Awesome.